So the very first question is, what is statistics? Statistics is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. I always tell students if there's one area of math that's probably going to affect you the most in life, it's definitely going to be statistics. The first thing we need to look at is how to read and understand graphs. Now, you've probably been reading graphs ever since you were little. However, this is just going to be a review, especially in terms like circle graphs. So just a review of how to compute some of these questions. So the first one says, how many more cesarean deliveries were seen in non-Hispanic white women than in Asian or Pacific Islander women in the year 2000? When you're dealing with a graph that has multiple bars, just make sure you pay attention to the key here. So the key represents all the different years. We're looking in this question for the year 2000. We are comparing non-Hispanic white women to Asian or Pacific Islander women. So non-Hispanic white in the green is going to be 23. In Asian or Pacific Islander in the green, again, we're looking at year 2000, is going to be 21. It's asked for how many more. We've talked about this a lot. How many more indicates subtraction. So at a rate of 2 more cesarean deliveries. Which ethnicity saw the least number of cesarean deliveries in 2007? So the nice thing about a bar graph is you can look at 2007, which is the dark blue, and kind of scan down and look at it. And you can see the least number in 2007 is going to be 28. And so that's going to be American Indian or Alaska Native. By what percent did the number of cesarean deliveries increase in Hispanic women between 1996 and 2007? So we need to find Hispanic women, which is here. 1996 is this light blue, 2007 is the dark blue, so we're going to compare 20 and 30. Now, keep in mind, when you see something that says percent increase, or even if you see something that says percent decrease, the very first thing you're going to want to do is subtract those two values. So when we subtract them, we get an answer of 10. 10 is now my new numerator in my percent proportion. My original amount, so 1996 would be my original amount, is going to be my denominator. And we are trying to change that to a percentage. Now, granted, you don't have to use a proportion to change this fraction to a percentage, but if you did, 10 times 100 and then divided by 20 is going to give you an increase of 50%. Now let's look at a line graph. So line graphs show change over time. So if you're ever wondering, like, when would I use a line graph? If we're showing something over a certain period of time, that is going to be a line graph. It says, what was the college participation rate in North Carolina for the year 1994? So notice you've got two different lines here. You have the nation, which is this blue color, and then North Carolina, which is this orange color. This is college participation rates. So the year 1994 is right here. Just pay attention to which one you're looking at. We're looking at North Carolina, so that would be 51%. At the start of which year did North Carolina pass the nation's rate? So you can see with multiple lines here, you can see where North Carolina goes above the nation's rate, and it occurs right here. Now, it does ask at the start of which year, so you want to be careful. Is it going to be 96 or is it going to be 97? Well, at the start of 96, you can see North Carolina was below. But at the start of 97 is where North Carolina overtakes the nation. So we would say 1997 here. And then between which years did the college participation rate decrease in North Carolina? So the nice thing about line graphs, you can easily see changes going up or down. So North Carolina is going up, 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 up. Still going up here, and then it takes a dip here. So between 2000 and 2002, there was a decrease. And then again, it starts going back up again, the college participation rate, and then it takes a dip again here between 2008 and 2010. All right, now let's look at a circle graph, or sometimes called pie charts. It says, the nice thing about pie charts in a question like this is which category represents the largest expenditure. This is the annual energy bill for a typical family, and it's talking about what percentages go to these categories over here. Which category represents the largest expenditure? You can basically look and see what's my largest piece of my pie. So you see 29% here is my largest piece, and that represents over here in my key, heating. Which category represents the smallest one? So my smallest piece of my pie is this gray color, which is electronics. What percent of a family's annual energy bill goes towards lighting? So I would find my lighting, which is my light blue, and find my percentage, which is going to be 12%. Now this last question is a little trickier. It says, how much does a family's annual energy bill goes towards heating and cooling? Now heating is 29%, cooling is 17%. So the very first thing we would want to do is take 29 and 17 and add them together. So if we do 29 plus 17, that's going to be 46% of their bill. And we're like, well, how much is their bill? It tells you up here their bill is $2,200. So what we would do is take 46% of $2,200 to see what percentage goes towards heating and cooling. So remember, you can use cross multiplication. We could do 46 times the 2,200 and then divided by 100. And so if we do that, 46 times 2,200 is going to give you 101,200, and then divided by 100, you get $1,012. Let's look at a couple more examples of circle graphs because they can probably be the trickiest of all types of graphs to understand. It says if the budget for your family was $4,200, how much would you spend on food? So here's another example. This is a person's budget. We know they have $4,200 total. The percentage on food here, I'm going to be using the percentage inside the pie chart because that's going to be a little easier to deal with. So we want to know food is 13%. So what is 13% of their budget, which is $4,200? Again, with cross multiplication, you'll do 13 times 4,200, and then we're going to divide by 100. So then we know on average they're spending $546 on food. This one says if you spent $1,300 on housing, how much would you expect to spend on entertainment? The problem with this question is whenever you're setting up a percent proportion, keep in mind it's the part of something out of the whole thing is equal to the percent over 100. The problem that we're missing here is unlike this one, we were given the whole thing. We were saying that their whole entire budget was $4,200. We're like, well, what is their whole budget, or what is the total? We're going to have to work backwards to figure that out. So what we can do is we can set up this proportion for housing. So housing is 34%. Now $1,300 is not going to go at the bottom because that's not the total. That's not their total budget. $1,300 is the part of something. That's how much they're spending on housing. So we can cross multiply and do 1,300 times 100 and then divided by 34. When we do that, we get approximately $3,823. Since we're talking about money, we'll round to the nearest cent. So we'll say 53 cents. This does not answer our question. What we just found out was the total amount of money that these people are spending. This is their average annual expenditure. Now, if we want to know how much they're going to spend on entertainment, we're going to set up a proportion for entertainment. So we're going to use 5%. So we're going to say, what is 5% of their total budget? Which is $3,824.53. So we're going to do 5 times $3,824.53, and then we're going to divide by 100, and we're spending on average approximately, if we rounded, $191.23. Let's look at one more type of graph, which is a stem and leaf plot. Stem and leaf plot, make sure you pay attention to your key because it's going to tell you exactly how to read it. So know in this case, when you see the 9 over on the left-hand side and a 2 over the right-hand side, that represents the score of 92. So like reading this here is going to be the score of 66. This is a score of 70. This is a score of 75. This is a score of 77, and so on and so forth. It says, what is the lowest score on the test? So it's nice with a stem and leaf plot because you can just kind of glance at it and say, okay, here's my lowest number down here, which is going to be 66. It says how many students scored an A on the test. So we're defining A in this case as a 90 to 100. So we're talking about this category right here. So we got 90, 92, 99, and 100. So there's a total of 4 scores there. So that's 4 students. And then most students scored what grade on a test? Again, this is probably the biggest advantage of a stem and leaf plot is because you can see, well, like how many students scored within each range. It's easy to see because this is my longest line here, is that most students scored in the 80s. So for us, an 80 is considered a B.